Hi guys, this is second topic. In previous section we have seen that moment of inertia for different rigid bodies and we have the formulas for different rigid bodies. I already said you that and you have some clear idea about. I also said that you just always keep in remember all those formulas because these formulas we are going to use in further topics. In a second topic in this session we are going to deal about torque, and this session I also try to complete the angular momentum, and the final topic is rolling. I just keep it those topic in my part 3. So this is most important thing. I already said that most of the need questions are asked in these areas and most weighted chapter. Here this is a topic to torque. Just know what's the meaning of torque. What's the torque? This is the force which causes the rotation. Got right? This is the force which causes the rotation of any object, any rigid bodies. The torque is the force which causes rotation. The torque, we have some simple formula. If you have completed your class 12, you definitely know this formula. The torque is equal to force into perpendicular length. This is cross product. You have definitely have the idea if you have completed your class 12. In electrostatics, you already read about it. So, this torque equal to F vector cross R vector. This L is a length, I just keep it as R vector, and torque equal to F R sine theta. The final thing, the torque equal to F into R sine theta. That's the basic idea about the torque. The problems are asked in this torque. The problems are asked in two areas. Just these are divided into under equilibrium condition and non-equilibrium condition. These are the two topics in this talk where the questions were asked. First we'll discuss about the condition equilibrium. Generally, according to Newton's laws of motion, we generally says that an object is said to be in equilibrium, then definitely the net force on the system would be zero and the net force on the body must be zero. This is under Newton's laws of motion. We already discussed Newton's laws of motion. Whenever the object is said to be equilibrium, the force net is definitely going to zero. But under this rotational dynamics, we have some another one point. What's that? That net torque also must be zero. These two cases are essential to say whether the object or system is said to be equilibrium in rotational dynamics. Suppose you assume an object. I am just giving some example. This assumes like a bar. I am providing 10 Newton on this direction, also 10 Newton on this direction, and center of axis rotation in this direction and this also this direction. Whether this system is said to be an equilibrium, first thing I can check whether the net force is zero here. Definitely one force 10 Newton force is acting upon in this direction, also 10 Newton force are acting in this direction. Definitely net force would be zero. Whether torque is said to be zero, no. Here in this direction also the torque is applying in this direction, and here also is applying in this direction. So torques seems to be in the same direction, so never it seems to be cancelled out. So torque here, net torque would not be a zero. Hence this system would not be in equilibrium. So this is non-equilibrium case. In order to say whether the system is in equilibrium, you have to confirm that both the cases, that force net is zero and torque net also is zero. Let's move on to a question. to have a better idea than how the questions are asked in this topic. Find the torque in a given diagram. I will give a diagram. Don't worry about it. So ask a question. Now what we need to find here is torque. What's the question? What's the question? Torque. What's the question? What we know already is torque equal to F into R, F cross product R. This we already knows that. R torque equal to F R sine theta. Here in this case, I can split this force, this 10 Newton force, to vector product. I am splitting out, you see. F cos theta. Here cos theta is cos 30. Here F sin theta, sin 30 degree. Here F is 10 Newton. I am just splitting these components alone. This is horizontal component and this is vertical component. Now this is R. You already know that this is R and this is 2 meter. I am just going to apply only torque. Torque equal to F is F sin 30 degree. Okay, this is F sin 30 degree. Because I already said that F into R sin theta. So here F is 10 Newton into what's R? R is 2 meter. And what is the angle sin 30 degree? Just I doing here. What's the value of sin 30 is 1 by 2. Finally, what's the answer? 10. That's what the answer about. So simple. Just got the answer. Let's move on to another question. This chapter is totally about the problematic. I already said that this a chapter where they are going to twist it. So simple question, you have to have some concept and knowledge. You can clear out any questions. Another question, slightly complicated, but you have some clear idea, then definitely you are going to do that. Find the tension in a string for a given figure under I just missed one case. This case is said to be an equilibrium case. I just give you a diagram that this are the diagram. These are the two strings as connect with a ball B and this A. These are two strings, have tension 1 and tension 2, and it is in equilibrium case. So I need to find tension of both these strings T1 and T2. Can I really make it here? Whenever the system is said to be an equilibrium, we have 2 points. Is that first point is F net is equal to 0, and second point is torque net is said to be 0. In this, the direction of the rotation, when it is said to be in equilibrium, this is said seems to be in this direction, and this seems to be in this direction. And weight of an bar seems to be in this direction. Gravitational force it seems to be in this direction. That's how we can make it from the diagram. Whenever the F net is said to be 0, this must be just missing this torque 1, torque 2. Whenever the said to be is an equilibrium condition, the first point is F net is said to be 0. So I'm just going to make it this net force for the entire system. These two tension are acting upon in upward direction. So T1 plus T2 and gravitational force acting towards downward direction mg is equal to 0 because F net is said to be 0. So upward force minus downward force is definitely equal to be 0. So T1 plus T2 equal to mg. This was my first equation. From the second condition, what I can make it? From this, what can I make it? Here this is torque 1 and this is torque 2. They are in opposite direction and the net torque would be 0. This is under the second condition. So when I was said to be in equilibrium, these two conditions satisfy. So T1 must be equal to torque 1 must be equal to torque 2. This is my second condition. Generally, what is the formula of torque? Force into perpendicular length. Here torque is what's the force here? Tension at this point, what is the torque, and this point, what's the torque? Here force is tension, and what is the perpendicular length? And this what the perpendicular length. If it is supposed to be L and seems to be this to be center and this to be the L by 2 and this is to be L by 2. So what's the length? It is seems to be a 90 degree. Now see, the length is L by 2 into sine theta. Here theta value is 90 degree, sine 90 value 1. I just leave it. So torque 1 is, what's the torque 1 is T1 L by 2. I say. Similar for torque 2, T2 into L by 2. This is what I find. I am just going to apply this in this case. What it happens, let's see. Applying this equation, in this equation, what will get? T1 into L by 2 equal to T2 into L by 2. This is what we get. L by 2 and L by 2 cancel. What we finally get there? T1 equal to T2. 3. Also question is find the tension for a string. Now I am going to apply this equation, this third equation in my first equation. Okay, because we need to find what's the value of tension. So I already know that tension T1 and T2 are same. They are similar. I just going to use a common term T for both. Okay. So I am applying this in this equation. What we get? T plus T equal to mg and 2T equal to mg and tension equal to mg by 2. That's it. So the answer. We just finally found that tension in a string for a given diagram or given figure under equilibrium condition. slightly twisted, but you have a real concept of knowledge, you definitely can make these questions. That's it. Just moving for a second case, and it's said to be non-equilibrium cases. Most important topic. And it's said to be a non-equilibrium for cases whether the net force on the system must not be a zero or net torque in a system must not be a zero. In these cases, you have another formula for a torque. What's that formula is torque equal to I into, it's not a cross product, it's just torque equal to I into angular acceleration. This was a new formula you just keep in mind. You already have a clear idea about the angular acceleration, because in my previous session what I take is circular motion. Why I have taken that, because of this chapter the idea of circular motion really comes in place. That's why I've taken the circular motion in my previous topic. Now this would be easy because the angular acceleration what I am just teach in a circular motion is same for this. I'm just going to keep revising some key formulas in circular motion because we generally use those formulas. What's the angular acceleration is change in angular velocity with respect to time. And what is angular velocity is change in angular displacement with respect to time. Just revising the formulas alone. It's important formula. Now I'm going to take another question for you. Revise. The instantaneous angular position of a point on a rotating wheel in given by equation is torque. Angular displacement is, what's the given question? The angular displacement is 2t cube minus 6t square. The torque on the wheel becomes 0 at. They said that the torque on the wheel becomes 0 at. We need to find at which time. At which time the torque seems to be 0. This is what the question. This is a non-equilibrium case. So we know that torque equals to I into alpha. When torque is said to be 0, then definitely the angular acceleration also said to be 0. When torque seems to be 0, then angular acceleration also must be 0. Because the inertia must be the constant one for any system. Suppose you assumes that it must be a sphere, it have a constant value, it never changes. For a same object, the moment of inertia never going to change. But this torque and angular acceleration may be changed. Here, the torque seems to be 0. Definitely the angular acceleration must also be 0. When the angular acceleration seems to be 0, we don't have the angular acceleration here. Or the given in the question is angular displacement. But we can make this angular displacement to angular acceleration. How? We have the formula. So find the angular acceleration. First I need to find the angular velocity, that is change in displacement with respect to time. Just I want to differentiate this. If I am differentiating is, it will come I get answer that 6t square minus 12t. This was the omega angular velocity. Now I need to find that what's that angular acceleration. So this I want to differentiate it again. So change in angular velocity with respect to time is acceleration. So already I have the value of angular velocity, that is I am differentiating it again. 6t square minus 12t, sorry, is 12t, and just getting the value that 12t minus 12. That's, I just got it, the angular acceleration finally, 12t minus 12. We already knows that when torque seems to be 0, the angular acceleration also must be 0. So at that point, the angular acceleration seems to 0. Already said that. So I am computing and just I am moving this equation to be here. What I get that 12t minus 12 is equal to 0 and 12t equal to 12 and t equal to 1. That's it, I got that. They ask you to find the time at which the torque seems to be 0. So at this time the angular acceleration seems to be 0. When the angular acceleration seems to be 0, definitely the torque also must be 0. So we have found that time. That's it. Just going for another question. Non-equilibrium case. A force is acting on a hinged disc. Hinged disc pulley. Find the angular acceleration. Suppose this seems to be a disc. The force is acting on a hinged disc. A pulley seems to be like in this shape. Find the angular acceleration. That's what the question. It is said to be a non-equilibrium case. So I generally make how to solve it. We already know that torque equal to F r sine theta. Here theta seems to be a 90 degree. So torque equal to F into R. We already know that under a non-equilibrium case, a torque equal to I to alpha. The question is this. We want to find the angular acceleration. Now, what's the question? This is a disk. We already know that what's the moment of inertia for disk? That is mr square by 2. So I am applying here alpha equal to F into R. Just the square and the R will be cancelled out. And angular momentum equal to 2F by M. This was the angular acceleration. This was the question. We found this. So these kind of questions were asked. That's it. We are completing the topic of torque. Okay, let's see some another question. So you need some SI this radian per second square. Angular acceleration, the SI unit is radian per second square. Just move on to another question, a similar model. A rope of one of hollow cylinder of mass 3 kg and radius 40 cm What is the angular acceleration of cylinder if the rope is pulled with a force 30 Newton? A similar question in a previous model. I just give you a diagram here. This is an hollow cylinder. It's pulled with an from a rope is on an hollow cylinder and pulled with an force that is 30 Newton. And the radius is 40 centimeter. Before question we don't give any numerical values, they just only ask angular acceleration. But they given here in this case we are given some angular numerical value for r and m, and they asked us to find the angular acceleration. Same like that, what's a torque equal to F into R sine theta. The theta is 90 degree, sine 90 will be at 0, sorry, sine 90 will be 1, so only F into R. The torque we already known as I into alpha is equal to F into R. What's the inertia? Inertia of a hollow cylinder, I already discussed that inertia of a hollow cylinder and inertia of an ring would be same. What's the value of inertia? M into R square. That's what. For both hollow cylinder and ring would be same. So I'm making here M R square into alpha equal to F into R. The square and R would be cancelled. Alpha equal to F by mr. F by mr. What's the F value? 30 Newton by what's the value of mass? That is mass they have given that they are 3 kg by what's the value of R? The R is 40 centimeter. Just cancelling out 10. And this is in centimeter. I need to convert into and meter. So I just make into 10 power minus 2. I'm moving out. Upside will come 10 power plus 2 by 40. Alpha equal to 1000 by 40. Cancelling out L 25. Then angular acceleration would be 25 radian per second square. That's it. These kind of questions are asked in your NEET exam. So simple when you know these formulas. That's it. I'm just closing this topic. In your next topic, I'm just going to try to complete the angular momentum as well as the ruling. So that's all. Bye guys.